All right, good day, everyone. I'm going to go ahead and do the notes on arc length and radian measures. I went ahead and pre-filled some stuff in just to save some time. So you guys already have the definitions done because that is something, well, you might not have them done, so you could technically add these to your definitions that everyone will have to do on Friday. So the objective is to find the length of an arc as well as convert degrees to radians. So these are the definitions. Again, pause the video as much as you need to get these copies. Sorry, this is a little sloppy. Okay, number one, arc. Unbroken part of a circle consisting of 2 points called the endpoints and all the points between. So example, arc AB. So like right here, that would be AB, right? 2, arc length, the distance along a circular arc in the linear unit. So that distance right here. 3, concentric circles, 2 circles with a common center. Okay, so they share a common center. All right, this is the equation you're going to need. We're normally going to use the one on the bottom, so that's why I start. But you do want to write both of these down to find the arc length. So you can do the proportion one. You can take the angle over 360 equals the arc over 2 pi r. R, the one that I'm normally going to use is you take the center angle, put it over 360 times 2 pi r, and r is your radius. So again, pause the video as much as you need. And then I got distracted by something. Again, pause the video as much as you need. Copy these into your journal. This is the one that we're going to use most of the time. All right, so our first example, I'm going to just move this one page up so I can write. It says, find the arc length of AB. All right, so I'm going to, you can technically do both, but I'm going to just stick with option 2. Can you guys see that okay? My pencil is writing so light. I don't really want to do my math and pen. That one's better. Okay, so we're going to use the formula. So I'm going to go and just rewrite the formula again. Okay, so now what you're going to do is you're just going to plug stuff in. Well, our central angle is given, in this case, is 60, so we don't have to do any conversions. All over 360 times 2 times pi times, what time symbol was it? 9. Okay, so you can either use the pi button or 3.14, so let's get our calculators out. And we're going to do 60. Can't get this in here. Divided by 360 times 2 pi 9. All right, so it turns out to be, everyone can see, about 9.42 units. Just type it in the way you wrote it. All right, let's do another one. This one has a clock. Okay, so this problem says a clock minute hand is 10 centimeters long. How far does the minute hand travel from 12 to 12:15? So if you want to, you could draw yourself a clock. Okay, all right, so there's this. Okay, so you want to actually figure out what the central angle is. So we're going to do the conversion. So if you have a circle, you can see that this is 1/4. So you would take the 15, and this is clock's out of 60. So this is 15 minutes. So you would do 15 out of 60, which turns out to be 1/4. Okay. To help you get the central angle, you'll take 360 times 1/4, and it gives you 90. So that's our central angle. It's going to be 90. All right. So now we just take the formula again. Okay, central angle, which is 90, put it all over 360 times 2 times pi times 10. Okay, because, oh, I forgot to put the 10 in the drawing. 10's right there. Okay, so 10's our radius. So get your calculators out again. Let's just type it in. Okay, turns out to be about 15.7, or you can do 15.71 more likely. So I'm going to do S equals 15.7 centimeters since it was 10 centimeters long. All right. Again, as you're doing this, you guys are going to need to pause because I already pre-written my equations just to make it go a little quicker, and the video is not so long, so you do need to pause. Make sure you guys get all these examples down. I think this one has a total of, I think, is it 4? Yeah, 4 examples. So let's move on to example 3. Okay, so this one has 2. We have an A and a B, and we're just going to convert into radians. So let's just move this a little bit. All right, so a radian measure, this is the definition, another one. It consists of the proportionality for arc length. So you have m over 360 times 2 times pi, okay? So you have your angle right here, which is right the m. So if I have 180 and I want to go into radians, my formula would be m 360 times 2 pi. So I would take the 180, put it on top of 360, times 2 times pi. Okay? All right. If it tells you to leave it into radians, pi is your radians, so you can just leave it. So don't multiply that through. So let me just put this in the calculator real quickly here, guys. 180 divided by 360 times 2. Okay, it's 1. Do not multiply this in. Okay, so I'm gonna, you see I just typed it in and it turns out to be 1. Well, so that's still technically pi, or you can just do pi, leave the pi, and then write the word radians. Okay, and we're done. Or if you really wanted to, if you don't want the pi symbol on that one, you could do 3.14 radians. Okay, so either one, but this time I always leave just the pi. So we're gonna do the same thing down here on this one. So let's try it again. We're gonna take, the formula is m 360 times 2. Just don't multiply the pi through. Do everything else. So you're going to plug in a number on the m, which is 60, times 2. Again, do not multiply the pi through. So let's put that in our calculator. Trying to see where you can get see my calculator. So can't really get it. Okay. So we'll do parentheses 60 divided by 360. Close it, times 2 is 0.133. If you want to convert that, you remember you hit math, fraction, and there it is. It's 1/3. Okay? So this is actually going to be 1/3. Okay? You remember you take the pi, you stick it on it, like that, and then write radians. And that's all you do. So these are pretty easy to do. Okay? We're going to do one more example, guys, and then we're done. Sorry, that's a little crooked. Let's straighten that up for you. Okay, so again, example 4. Find the length of the intersected arc in the larger circle. Okay, so the first thing we're going to want to do is we want to find the central angle. Okay? So our formula is S equals m over 360 times 2 pi r. So we have the smaller arc here, so I'm going to put in 6 equals m, which we don't know, over 360 times 2 times pi times our radius. Okay? Our radius for the little one is 8. Okay, so we can work this part out here. I think it turns out to be 50 point, let's just put in the calculator and see. 2 times pi times 8. Turns out to be 50.27. So we have 6 equals 50.27 all over 360 m. Okay, don't forget the m. Okay, so our goal is eventually is to get m by itself. So I'm going to get rid of the 360. The way to get rid of 360 is by multiplying 360 on both sides. Okay, so I'll do 360 times 6, which gives me 2,160 equals 50.27 m. And you guys know what to do now. You just divide that 50 out, 0.27 on both sides. So let's do that. 2160 divided 50.27 turns out to be about 42. So m turns out to be 42.97. So now to find the arc length, number 2. Okay, we take our formula, S equals M360 times 2 pi r. Okay, so we have the angle, which is 42.97, all over 360. So you just plug in all this in, times 2 times pi times, okay, this is the thing, you want to make sure you get the correct radius, guys. So it's not going to be 8, and it's not going to be just the 12. You have to add both of those, 8 plus 12, to get the full one, to get the big circle, which is actually turns out to be 20. All right, so let's go ahead and just type all that into the calculator. And then we're going to have 2 times pi times 20. It turns out to be about 14.99. I'm just going to round this to 15. And now we're done. All right, again, oh, you can't see the 15. All right, again, make sure you guys pause the video as much as you need. You do need all 4 examples, copy, and then you're actually going to be doing book work today. I did post the pages for people that are in person and you don't have your textbook with you, but the problems will come out of your book.